Welcome back. This is Richard Kuyava, Professor of Geography, St. Michael's College, and member of the Social Dimensions team of the Building Resilience to Extreme Events EPSCoR project funded by the National Science Foundation. This is a continuing series of videos that are demonstrating the use of the clean water roadmap tools provided by the Department of Environmental Conservation in Vermont. And if you've watched the previous videos, we're picking up exactly where we left off. But let me quickly, for people who are coming in cold, let me quickly bring them up to speed as to what we're actually looking at here. So we have been working on the Clean Water tool. It's a cloud-based GIS tool. We have some Clean Water roadmap tools here which we're using. We have some map layers which we've been using to look at legends and opacity. And if you're unfamiliar with these facets of a cloud-based GIS, might I suggest that you watch one of the earlier videos, and hopefully there will be links in the comments or in other web materials that support this work. So I need to get cracking here, and what we're looking at here is, let's just review very quickly. We're looking at a baseline map of the National Hydrography Data Plus catchment scale. We're actually looking at cropland, and so we're looking at the total phosphorus yield in kilograms per hectare per year for cropland at the scale of the National Hydrography Data Plus scale. And the color scheme we've been using is a color scheme that does not use red or green, and so it's available for people who are colorblind. I'll switch it from green to red, but if you do fall into that category of color blindness, that's the place to switch it so that things will work for you very clearly. And I'm zooming out on the map here. And what you'll see is that the geography of total phosphorus yield from cropland really varies quite significantly. We'll go back to all land types here. And this is a choropleth map. This is a choropleth map. And so we see the color ramp of the extremes are red to green, and just so that we can show it again, there's the legend. There's the legend. We can also adjust opacity. So 0 means completely transparent. That's 50% opacity, and that's 100% opacity. We can also click on info, which tells you what data we're using. And here's the legend. And just to remind you that when we change the variable, the legend changes as well. There are these water quality blueprint variables, which I haven't used yet. I'm sticking strictly with the phosphorus for the minute. And I'll try to come back in a separate video and use those water quality blueprint variables, color scheme, and so on. So we've basically got things in a position where we actually know what we're doing in terms of different layers. They're the town boundaries, they're the county boundaries, these are village boundaries if you wanted to zoom in. Everything has to redraw. And so this sort of tells us these are the tactical basin lines, these are the HUC-12 lines, and so we can make the map very busy We can make the map very busy, or we can minimize the number of layers. We'll keep the basin program on and stick with a single layer or two. And every time you alter the layers that are being displayed, the map has to redraw. Remember, it's in the cloud. Faster internet, faster refreshes. So let's just go back here. Let's go back to the tactical basin scale, and I'm actually going to go home. And this is a map we started out with earlier on, and what we're going to do now is we're actually going to start to use the catchment dashboard tool. And the way the catchment dashboard tool is programmed, is exactly the same for different geographical scales, although the information that is displayed may be different. But let's get it going. So we're going to unminimize it, and I want to orient you to the dashboard. And so just so that we can get a good look at it, I'm holding the left mouse key down and I'm moving it up to sort of steal some screen real estate. And there is a nice information, and so if we click on it, we're going to get a little splash screen that's going to explain what's actually going on. I'll let you read that on your own. I'll do it by demonstration. I'm going to shrink this down a little bit so we just have enough. Let me move this up a little bit so we've got on the Canadian border. And now we've got the full map, and we've got enough so that we can see this table. And what we're actually going to do now is we're actually going to click on the map in one of the tactical basins. So we're going to click on this. And you'll notice that what happens here is we get a little label as what's going on. What's the basin name? Well, it's the Otter Creek, Little Otter Creek, Lewis Creek Tactical Basin. Okay, perfect. If we close that, the dashboard, the name changes to nothing. So let's click on this. This is the Southern Lake Champlain Basin, Tactical Basin, right? Now let's look at what's happened here. Something's happened in the dashboard window. And I'm actually going to move this up to get myself a little bit more screen real estate. And so what's actually happened here is now we have a tactical basin name. Okay? And we start to see information. And so we start to see the information that is driving the mapping. And so for the Southern Lake Champlain Tactical Basin, we've got a total phosphorus load, we've got a mean yield, we've got an area in hectares, and the water quality blueprint indices are not actually calculated at this scale, nor are the percentage rank. And so they're all not available because they're not calculated. But some other stuff happens here. We've also got a pie chart which shows the annual total phosphorus load by land use, land cover group. We've also got the land area by land use, land cover group. And so we got a quick picture on pie charts of these different land use, land cover groups. And these land use, land cover groups have come from remote sensing and are part of the model. If you float over any individual pie, don't click anything, but you'll see that it will give you the total phosphorus load for that slice, and it will also give you the percentage of the total phosphorus yield. The total phosphorus load for this particular tactical basin. There are some more things to see here. So let's just take a pause and review the information that's provided step by step. So this actually shows you the ratios and percentages of land use and land cover groups by hectare. Okay, let's consider some other things that can be derived here. We've got a baseline summary, and we've got another little splash screen indicator. So let's click on that. The values in the summary table below represent the average baseline characteristics. These values are updated when you select a new tactical basin on the map. One thing to notice very carefully: these values always represent the catchment basin as a whole. And so these do not break down. The pie charts do not change if you choose a single land type, because they're made up of different land types. It's very important to spot that, just in case it disorients you. So we'll close that. Let's just demonstrate that, just to be clear. Let's sort of go halfway up. Let's just click on a different basin. So let's click on Missisquoi, and you'll see what actually happens is the pie charts change, and so the product is functioning perfectly well. This is the Lamoille Basin, and this operates pretty quickly. It'll operate more quickly based on the speed of your internet. A couple of other things to show. Here, so we're looking at the Lamoille Basin here. Here, there's a little link that says Show Sub-Basins. Move this down a little bit. We'll try to keep these pie charts on screen. Show basins, sub-basins rather, and what that does is it looks at the next scale, excuse me, it looks at the next scale down in terms of the sub-basins for the Lamoille Tactical Basin. And these are the HUC-12 IDs for those sub-basins, and here are the names. It gives you an area for those sub-basins. It gives you the base phosphorus load. It also gives you the base total phosphorus yield. And then it's got the water quality blueprint indices, which I'm actually not going to talk about. But you get the idea. And you can actually export this table if you want to do some other kind of display, if you want to sort it. You can actually export it. It will open as a spreadsheet. Let's close that up. So that's going to happen. There's one other thing we need to just sort of check out here. Actually, there are a couple of things we need to check out before we change geographical scale and watch the same operations being done by the program. These pie charts, which we've floated over, that imagery, if you like what you see and you think it's going to be useful in a piece of research or a report, you can actually export those as images. And so if we click on this, it will download, we'll download a JPEG. It will shoot a JPEG down there. I'm not sure how that's going to open. For me, it just opens in Windows Photo Viewer. But there it is, a nice high resolution JPEG. It's not interactive now, it's just the JPEG of the total phosphorus load by land use, land cover group. Okay. Oh, I forgot. You can do that for land area too. It's one other thing I want to do. I just want to change the variable that's being displayed on the map to yield. The pie charts continue to display the total phosphorus load. Now, we're in the Lamoille Tactical Basin, and this is the next step in the display of the data. I'm going to win us a little bit more screen real estate, just a little bit. Okay. So we know about showing the subbasins. We know what it's actually showing here. So we're going to click on cropland for this basin. I'm just going to click on it, and a screen opens. And this is a screen that is giving you a sense more generally of the breakdown. And so it's a disaggregation. It's a disaggregation of the annual total phosphorus load for this particular tactical basin for cropland. And you can see in here, it's also giving you the yield, the mean yield. And it also, it's also making for you a disaggregation of cropland. And so we can see here that corn and hay production on non-clay soils yields almost 64% of the total phosphorus for this particular tactical basin. If we float over something else, corn and hay, 15%, idle, 6%. What's this skinny one? Corn on clay soils. And so the biggest slice is corn and hay, the rotation. Excuse me. And so we also here, now that we've clicked on the slice, we could close this and click on any of the other slices, but we can look at some of the others. And so we can look at pasture, we can look at developed land. And what it's going to do is it's going to give you a total phosphorus load budget at this geographical scale for, in the developed category, it's going to give you low density, medium density, high density residential. And you can see, you can get a sense of what's actually going on here. Here's that little ladder. And so what that's going to do is it's going to let you download a JPEG of the chart. If I just click on it, that's what it's going to do. And so it's just grabbing the chart. So if you want to use this in a report, you need to put on your own geographical labeling so there's no confusion. Okay, back to cropland for a second. And there's one more thing I want to mention, and that is that there's a tab here that says BMPs. And if we click on that, this tells you the best management practices that are typically appropriate for the land use land cover group that we've selected. And so there's a list. It's just a list. If we go to farmsteads, if we go to developed, if we go to forest, and so this is a nice, convenient inventory, if you weren't familiar with them, of the best management practices. So, let's recap for a second, and then what we're actually going to do is we're going to change geographical scales. So, what we had done is we've opened up the catchment dashboard and gotten oriented to it. And we figured out that for any selected polygon on the map, that the Clean Water Roadmap tool will build a baseline summary of that particular catchment basin. We'll change scale in a second. It'll also give you an annual total phosphorus load budget. It'll also let you look at some additional disaggregated information. It will also let you look at, in tabular form, the sub-basins. So let's change something. We're going to go over here, and we're not going to use the tactical basin scale. We're going to use HUC-12. And it's going to take a second to run this. But what's going to happen on the map is, and I'm actually going to hide the dashboard indicator so that it refreshes the whole map, but I'll keep it high on the screen. And so what we now have is we have the HUC-12. We have the HUC-12 basins. I'll switch off the tactical basins, and let's zoom in a little bit. There we go. And let's pick a HUC-12. Actually, let's put the tactical basin back on. And let's get up into the Missisquoi tactical basin up here. We'll let the map refresh. And let's pick something. We're mapping phosphorus yield here. Let's pick an area with a relatively high phosphorus yield. And so I'm going to pick this. What is it? Well, let's take a peek. Let's take a peek by adjusting the opacity so that if we zoom in a little bit, what are we looking at here? We're looking at, let's put the town boundaries on. We're looking at a big piece of Highgate and a piece of Franklin. I'll switch those off. But what we're going to do is we're going to click on this HUC-12 basin. I've clicked on it. This is the Rock River Basin. This is the Rock River Basin. And you can see the HUC-12 ID. You can see its name. And just one little thing here. It's showing us, it says 1 of 2. It means that there are 2 data screens here. So let's just click on the little triangle to see what the other data screen says. Oh, it's just telling us what tactical basin it's in. It's in the Missisquoi. So we're in here. It's highlighted. We're looking at phosphorus yield. All stuff we've done before. But now let's go into the catchment dashboard. Now we've got some other things happening. Okay, so it's a HUC-12 basin. It's the Rock River. It's in the Missisquoi tactical basin. Here's the total phosphorus yield. Here's the mean yield. Here's the area. This is what it ranks. This is what it ranks. What percentage this particular HUC-12 basin ranks in terms of its total phosphorus and mean yield. So it's in the 90th percentile. In terms of the whole basin, it slips down a little bit, 86, 86. It's also got the water quality blueprint indicators. I'm not actually going to talk about those. I might do that in a separate video. But what we've done is we've got this going. Familiar pie charts. Look, cropland, big proportion of the phosphorus load, small proportion of the overall land use, land cover. 27% of the land cover, almost 70% of the total phosphorus yield. Float around on this, you get the idea. Same drill, click on the subbasins. But now what we're looking at for subbasins is not the HUC-12, because we're in the HUC-12. We're looking at the NHD plus basins. Gives you the area, the phosphorus load, the phosphorus yield, and then the water quality blueprint indicators. And you can export this as a table, as we talked about before. Now that's kind of cool. Again, we can export these graphics. Not going to do it this time, but you can. And if we click on this cropland wedge, it's going to open up for this HUC-12 basin, what's actually happening in terms of the various ratios. And here, this is just the pie chart in a list. Let's go to baseline. This tells you the baseline annual phosphorus load. And again, if you float over things, it tells you the cropland mix and the relative proportion of each in the total phosphorus load. And this is getting down into the weeds here, but this is precisely the kind of information that you either A, will have been tasked to look for, or B, need to think about what kinds of land use land covers are actually generating the phosphorus at the highest yields. And so that's why this Clean Water Roadmap tool is informational as well as educational. Same idea. It gives you a sense of what's going on, the developed land, different density, roads, forest cover, grassland, wetlands. Everything is disaggregated in here and things change. Cropland, if you click on the BMPs, it's going to tell you the same list. So let's recap and end this particular video, and we'll pick up in this at this stage in the next video. So we know about the legend, we know about opacity, we know it gives us information, we know about all of these things from previous videos. We know that we can change the color so that if a user is colorblind, things will work perfectly for them. We can switch on a streams layer and so on. Okay, so this has allowed us to actually visualize some basin results using the baseline data. And what we've done is we've looked at different geographical scales, and we've looked at the way in which the program structures the way information is displayed and can be exported in tabular and in graphic form, and the way in which those are linked to best management practices. And let me stop that video here. We're going to come back and we're going to look at another facet of the Clean Water Roadmap tool, which is looking at the TMDL reasonable assurance scenario. And thanks for watching.